Welcome to Let's Do It 5.8. In this LDI, we're going to start into our investigation into measurements of variability. And what we're going to see is that there are, as with the measurement of center, many different ways of measuring variability. It turns out there'll be two main ways we're going to do it. One, this is associated with the median, and one that's associated with the mean. Okay? So let's get into this and start talking about why do we want to measure variation in the first place. So consider these two frequency plots that we've got going here. Both these frequency plots have a mean of 60. Notice they're both symmetric distributions. But we notice that they're not the same distribution. I mean, if you just said that I have two distributions with a mean of 60, you're not telling me the whole picture. There's other information that I might want to know. So notice in this particular distribution, or we'll call this one, say, distribution A, and this one distribution B, that we can calculate the range, with the range being simply the difference between the min and the max, where in this case the min is here and the max is here in distribution A. By simply taking the difference between those two numbers, we would have created the range. So if we take 61 and we subtract from that 59, that will be equal to the range for this distribution, which is 2. Okay? So let's take a look at the range in the other distribution. Well, notice this distribution goes from 55 to 65. So in the case of this distribution, if we were to calculate the range, our range would go from 65 minus 55, right? Which would give us a range of 10. And you go, okay, well that's cool because we notice now that the range is larger in distribution B, and therefore it has more variability in it. And you say, okay, let's move on. Sounds good. Use that for my measurement of variation. Well, not so quick. It turns out that the range is very limited in its usefulness as a measurement of variation. Good rough guess, but take a look at these two distributions. Again, we'll call them distribution A and distribution B. Okay. Now, if we calculate the range in the first distribution, we see that it's 20 minus 30, which is 10. And we take a look at the range in the second distribution, and it's 20 minus 30, and it is also 10. So yet these are very different distributions, yet they still have the same means too, don't they, right? Both of them have a mean of 25. They're both centered about 25 on both distributions. So they have the same ranges and the same means, yet they're very different distributions. And it turns out that distribution A has much more variability in it than distribution B does. And to get why that's true, think about it this way. If these were, say, bag A and bag B, and this is the distribution of my vouchers, we would expect that the most common voucher we're going to yank out of bag B is going to be somewhere around $25. Where in bag A, the most common voucher we're going to pull is a $20 or a $30. So notice you've got much more variation in the value of the vouchers in bag A that you'd be pulling out of the bag than you would be pulling out of bag B. Okay. So the first measurement that we're going to talk about of variability that turns out to be a very useful one is called the interquartile range. So before we can get to that, we need to do a few definitions. So we're going to find what are called the quartiles. And all the quartiles are, they're very simple, really. I mean, concept, they can be kind of a pain to calculate, but they're actually very simple in concept. The first quartile, which we'll label as Q1, is the 25th percentile, and that means 25% of the data fall below it and 75% of the data fall above it. Okay? The median, we've already talked about what the median is. That's our second quartile, or Q2 if you want to call that, and we know 50% of the data fall below it and 50% of the data fall above it. Q3, which is the third quartile, or the 75th percentile, 75% of the data, or 75% of the data fall below it and 25% above it. Okay? So let's go find our quartiles for the age data. So to do that, we're going to get out our calculator. And what we're going to do is go into Stat, go to Calc, and we're going to go to 1var Stats, and then I'm going to go Second List, and the list I'm looking for is number 7 here, my age data. Remember, this is the age data from the Monday, Wednesday, Friday class. I'm going to hit an Enter. And let's first of all notice that X bar is at 26.5. Let's keep that in mind. And then let's scroll down and take a look at the data here. We notice that the median is at 22. Well, that's because if you recall when we did a histogram of this data, it was skewed to the right, so the mean got pulled towards the skew. But even more importantly, as I scroll down below down here, I see the minimum, which was 16. I see Q1, which is 19.5, the median, which is 22, Q3, which is 32.5, and the max, which is 59. It's really nice. In other words, we were able to get all of those numbers very simply from the calculator. Now, as we'll see in just a minute, these 5 numbers have a name. They're called the 5-number summary for my set of data. Okay? All right, let's keep moving here. So, the 5-number summary in the box plots. Okay, so what was our 5-number summary for the set of data that we just produced? Well, the minimum, we saw just a second ago that the minimum was equal to 16. Okay, and I'll get my calculator up here again so we can keep these numbers up where I got them. Q1 was at 19.5. Okay, so Q1 is equal to 19.5. We saw that the median was at 22. And Q3, let's see, I'll have to go back and take a look at that again. I don't quite remember what Q3 was. Q3 was 32.5. And then last but not least, we had the maximum, which was at 59. Okay, so let's get down here, and the maximum was equal to 59. Now, if we take these numbers, which again, as we said just a minute ago, are called the 5-number summary, and we plot those 5 numbers on a number line, and then pretty them up a bit by putting box and whiskers on them, then we will have created what's referred to as a box plot. Okay, so in your textbook you'll find more information about the box and whisker plot, but I'd like to go ahead and do a box plot of the age data that I have from the Monday, Wednesday, Friday class for you. So to do that, I'm going to go back to the calculator, and we're going to go over to second y equals to get into our stat plot menu. I'm going to go into plot 1. I'm going to turn it on, hit a down arrow, and now I'm going to hit a right arrow 1, 2, 3, 4 times to get on the box plot. That's what's called a standard box plot right there. It's the 5th graph choice in our types. So I hit an enter to select that. Notice if you don't say please, this calculator won't do anything. Let's go down to our X list, and let's change the X list to our age list. Okay, once I've got all that information put in there, I'm going to go for a zoom. And then we know that if I hit the number 9 in the zoom menu, I get a zoom stat. Okay, voila, that is a box and whisker plot. Now, it's a one-dimensional graph. It's basically a number line graph. And if you press your trace key, you'll see that the cursor of the frog now goes to the 5-number summary. Let's hit the right arrow 2 times to get over here. Notice it's at the min, which is 16. Hit the right arrow once, and you're at Q1, which is 19.5. Q2, or the median, is at 22. Q3 is 32.5. And the maximum over here at 59. So the thing to notice about a box and whisker plot is that the box, which is this piece right here in the middle, the box, the lower end down here, that part is Q1. The upper end of the box is Q3. The line in the middle is the median. And then the endpoints of our plot, at either end here, those are going to be the min and the max. So you get the 5-number summary right off the box plot, or you create the 5-number summary to make the box plot. So it's the min, Q1, the median, Q3, and the max. Okay? All right. So now here we're ready to start talking about our first measurement of variability. It's referred to as the interquartile range, or the IQR. And simply, it's a new measurement of the range where now you don't use the max or the min to calculate the range, but instead you use the difference between Q3 and Q1 to calculate your range. So again, it is simply another measurement of range, just like we started off talking about at the beginning, but instead of using the max and the min, we're going to use Q3 and Q1. Okay? So let's go back to the box and whisker plot we just created, and let's take a look and see what the interquartile range is for our age data. Well, what that interquartile range is, as you can think about it, is simply the length of this box right here. Okay? So, if I do a trace, To find the interquartile range, we're simply going to take the difference between 19.5 and 32.5. So let's do that real quick. Take 32.5 and subtract from that 19.5. And when I do that, I get back 13. So the interquartile range for our age data is 13 years. So that's our measurement of variability based upon the median. All right? Well, the median is part of the numbers we used for it. It's a better way of thinking about it, I guess. Oh, okay, all that finally gets us to LDI 5.8. Now, I strongly suggest that you get out your textbook, because I was not able to make a very clean copy of this to put up on the slide, and that you do it from your actual textbook. It's going to be a lot easier on your eyes to see than what I've got up here. Nonetheless, we can read this. We can get this to work, okay? So it says the data numbered on the data on the number of questions answered correctly on an aptitude test were retained for 50 students. A stem and leaf plot for these data are given below. Based on the stem and leaf plot, which of these three box plots shown at the right is the correct box plot corresponding to these data? Okay. All right. So we have 50 students in here, don't we? Okay. So if we have 50 students in here, what's the position number going to be for the median? Trust me for a minute while I do this, because that's going to be an important thing. Well, if you got 50 students, right, then the position number is going to be 50 plus 1 divided by 2, all right? Now, all that is that's my position number for where the median resides. So that's what? 50 divided by 2, so it's what? 25.5 is where our position number is, right? So 51 divided by 2 is 25.5. So let's take a look in our data here, and let's see if we can find the position of the median, okay? So I'm going to actually physically count the data points, okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it looks like it's 90, because remember how to read a stem and leaf plot. By the way, you need to do stem and leaf plots in the reading. If need be, I would happy to do a supplemental podcast on stem and leaf plots, but right now I'm relying on your reading for that. So to remember how to read a stem and leaf plot, you first grab that number, that's the first digit, and then the second digit would be the 97 and 98. It's halfway between those two numbers. So the median for this distribution is going to be equal to 97.5. Okay, so let's see, which of these data sets has its median close to 97.5? Well, it can't be this one. We get rid of that one because the scaling is totally different on that one. So it's either going to have to be, oops, I X'd out the wrong one. I went to X out box plot C. Box plot B is still in the running here, so we won't get rid of him just yet. Okay, because take a look over here. We've got the scaling all wrong. We actually could have done that without what I did there, just knowing a little bit. But both of these, box plot A and B, appear to have the medians in somewhat the right spot. And they both seem to have the right max and mins, somewhere between 141 and a low of 68. So the only difference between box plot A and box plot B is their interquartile ranges, okay? So how do we find a good estimate of what Q1 and Q3 are? Well, if we know that our median position number was at 25.5, right, then halfway between between 1 and 25.5, in other words, if I split the lower half in half, I will have approximately the position of my Q1. So let's go ahead and do that. So half of 25 is roughly, let's just go say 12.5. So let's go count up to about the 12th data point or so, and we should have a good idea of what Q1 was. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's somewhere between around 82 or 83 is what Q1 is. Okay, so looking at these box plots, it looks like this box plot has is much closer to around 82 or 83, so it turns out that the box plot we want is box plot B. Okay, So I don't want to take it out of the running too quick there. All right. Well, there was a lot of stuff I just did real quick there. If you need any help with or clarification, any of these things I just did, please feel free to send me off an email, okay? And again, be sure and read up on stem and whisker, stem and leaf plots, and if you need any help with those, we'd be happy to help you with that too.